All right, so I'm on to the second example, the one we did before. We were, again, comparing those two triangles. We're trying to figure it out. The last one we were able to solve using that side, side, side. This one, I only have two side lengths, but I need to figure out if I can use that same formula that we did before, where we use that side angle side. So again, I've got a vertical angle. So that tells me that this angle on W and W is both going to be the exact same. So potentially I could use that side angle side to see that those triangles are going to be the exact same. So looking at those shapes, I'm going to try to figure out which ones will go ahead and have the exact same ratio. So I'm going to say, just for the sake of conversation, this one will be my top. This one over here will be the bottom fraction every single time. So as I look at them, I'm going to look at my numbers here, and I'm going to try to figure out which number is going to be the biggest number for both of them. As I look at it, 22 is the biggest between 20 and 22. And then for the other triangle, the other biggest side will be 11. So using those numbers, I'm going to set it up. Again, 22 was on the one that said top, so I'm going to use top. 11 was from the triangle that said bottom, so I'm going to set it up that way, 22 over 11. I'm going to do the division, 22 divided by 11. That gives me 2. All right, so far so good. Now I'm going to look for the smallest angle. The smallest angle for this one is going to be 20. Or not angle, the smallest side for that one will be 20. The smallest side for this one will be 10. So setting them up in a fraction, I'm still going to have 20 on the top. 10 will be on the bottom. I'm going to divide those together. That gives me 2 as well. So as I look at it, I've got this side, I've got this side, and I've got the angle. So I do have side, angle, side. Because it is side, angle, side, I'm going to say yes, they are similar. Perfect. All right, on to the next example. Okay, if need be, go ahead and hit pause for a second, and then you can draw that picture. Otherwise, I'm going to keep on going. So looking at this shape, they do give me 3 different sides. Because they give me 3 different sides, I can try to figure out, using that theorem, that side, 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 and if all 3 sides are going to be the exact same ratio, then I know that it is going to be similar triangles. So as I kind of talked with my 7th period class, I'm going to use what's referred to as kind of the Goldilocks theorem as I'm going for it. So again, I'm trying to match up the biggest sides together, the smallest sides together, and then the medium, like the just rights together. All right. So looking at this one, I'm going to compare my biggest sides together first. As I go through, I'm going to just say it. I'm going to say this one will be my top. This will be my bottom numbers. Okay. So my top numbers, my bottom numbers. So I'm going to look at my biggest side. Okay. 9 is the biggest number out of that 6, 7.5, and 9. Out of the 4, 5, and 6, the biggest number is going to be 6. That tells me that I can use those. I'm going to put 9 over 6. 9 divided by 6. If I divide those, it will give me 1.5. All right, so far so good. I'm going to look at my smallest number now. My smallest number is 6. And then my next smallest number is a 4. So I'll set it up this way. 6 over 4. 6 divided by 4, put it in my calculator. I come up with 1.5. All right, and the very last one, my middle one, my just right. If I'm going Goldilocks, I've got the biggest, I've got the smallest. Now I'm going for just right. It'll be that 7.5 and the 5. I'll put those in the fraction over here. I got 7.5 over 5. Punch into my calculator. I get 1.5. As I look, this number and this number and this number, they are all the exact same ratio. If they are all the exact same ratio, that tells me that it is yes, they are all similar. Sweet. All right. Example number 4. Go ahead and take a second to write it down if you need to. But as I look at these shapes, I'm going to redraw it again just so we can kind of see what's going on. Realistically, even though I've got this whole entire triangle right here, I've got this triangle right here, and then I also have a bigger triangle right here. Okay. So for that sake, I'm going to draw those two different triangles. I've got one small triangle right here, and that'll be M, N, and then a P. And then I've got that bigger triangle. Excuse me. The bigger triangle was going to be this one over here. Sorry, I'm running out of space. That will be my M on the top. R will be there, and then S will be down there. Okay. We're going to try to figure out if they are similar. So for my MNP triangle, if I look at that one, it's not too bad. This one tells me it's 10 on this side, it's 12 on this side, right? But now if I look at my my next triangle where it goes from R to M and then S to M, it doesn't give me a straight number, but I can figure it out by using addition. Again, for that R to M, this whole entire segment here, I know I've got this number and I've got this number. So I've got 15 plus 10. So the entire length on this side will be a length of 25. Again, that 15 plus 10. For my MS side, I'm going to have that 12 plus 18. So the entire length of this one will be a 30. Now that I have those two triangles where I can compare them together, and again, you don't have to redraw the shape if you don't want to, as long as you can understand that you're going to need to add those two parts together. Now I can go through and now I can figure out those ratios. Same thing. I'm going to put it together. I'm going to say this will be my top number. This will be my bottom number. I'll have my left side will go first. So if I write it down, I've got my left side that 10 over 25. Okay, if I divide them on my calculator, I got 10 divided by 25. That one's going to give me 0.4 as my answer. Okay, and if I do the next one, let me choose a different color. I'm going to have 12 over 30. 12 divided by 30, put it in my calculator, I come out with 0.4. Perfect. They have the exact same ratio there. I've got two sides. And now let's not forget, even though I didn't really show it right away, they both have the very top peak is the letter M. So they share that angle. So I've got side, angle, side, and it proves to be similar triangles. So I'm going to say yes, they are similar. I know one group had asked me what happens if they put the numbers in backwards, if they decide that it didn't want to be the top and the bottom. If they did it as 25 over 10 and then that 30 over 12. Okay, if you did 25 over 10, it's still going to work out to be a similar ratio. That 25 over 10 will be 2.5. Okay, this 30 over 12 will still work out to be 2.5. Again, it'll be a different number, but I can see that this one and this one are the exact same number. Just like on this side, I can see that this 0.4 and this 0.4 are the exact same number. No matter what, it's still going to follow through with that side angle side and show they are similar. All right, on to this property of similarity, and I'm going to explain what this is really saying. All right. And I'm not really going to get into the reflexive property, symmetric property, the transitive property. We're not going through. We're not going to be doing any proofs. But when I look at this shape here, okay, I'm going to zoom in just a smidge. Okay. It does want me to find QP and MP. So I'm going to go through and I'm going to figure that part out. But in order for me to figure out what these triangles are doing, I'm going to show you that it still works the same way. Doing these ratios. The great news is that I've got these two symbols right here. These two symbols show me that these lines are going to be parallel. Because of that, the ratio for this spot and this spot will follow that same ratio pattern. So when I go through and I'm going to set it up as, I'll just say the left side over the right side. So left side's over here, right side's over here. It'll still work the same way. I can set it up as 5 over x equals 6 over 3 3/5. So 3 3/5. Again, I'm still solving for that x, and I can still go through and put it together. So now that I'm putting these ones together, I'm going to be able to solve them using that cross product. Okay, just like what we did before. So let me work through it. Again, I've got 6 times x will be 6x. I'm going to rewrite this 3 3/5. 3 3/5 is the same as saying 3.6. So I'll take 3.6 times 5. So I got 3.6 times 5. I now get 6x equals 18. If I want to divide both sides by 6 to get x all by itself, my value for x is going to equal 3. Okay? So x equals 3. And if it wanted me to find QP and MP, QP is going to equal 3. I'll put it down underneath it. QP equals 3. MP is going to be both that 3 plus the 5. So the length for that one is going to equal 8. All right. I do want to show you, in case you were wondering, and if you're not, you're still going to watch it anyway, is that similar to what we did before, if I wanted to add those sides together, it will still work the same way. It'll still be the same ratio. The issue that, or not the issue, the bonus is that if we do it this way, because these parallel lines, it cut down on a lot of the work that we have to do. Okay. So when I did the triangles up top before, again, it would be 5 over, and I'm going to say 5 plus x. Because again, I'm going to add this whole entire side together, equals 6 over 6 plus, and again, I'm going to say 3.6 just so I have easier numbers to work with. Okay. Again, I just took this whole entire section, and that's where that bottom number came from. I took this whole entire section, and that's where that bottom number came from. Okay. So before I go through and start to solve this, I'm just going to simplify some things down. I've got 5 over 5x, or sorry, 5 plus x equals 6 over 9.6. Now I can cross multiply. I've got 5 times 9.6 is going to give me 48. So I'm going to write it over here. I've got 48 equals 6 times the quantity of 5x, or 5 plus x. Did it again. Okay, I've got 48 equals 30 plus 6x minus the 30 to both sides. Gives me 18 equals 6x. Divide both sides by 6. And I still get x equals 3. It's still going to work through the same way. But hopefully you saw doing it this way, doing it with that kind of the blue color that I chose, was about twice as much work. And I don't know about you, but if I can get away with not having to do as much work, I prefer that. Okay. On to the next example. Okay. I'm going to look at this one. I have got this angle here. Those ones are going to be vertical angles. So it's still going to work the same way. And if you can kind of envision, this whole entire thing is going to get kind of rotated around. But I know in between and I'll write this down. This will be my top side. This will be my bottom side. Okay, I know in between my one arc and my two arcs was going to be the x plus 6. Okay, and then in between my 1 arc and my 2 arcs was that 2x plus 6. Okay, likewise on the other one, I've got 8 here. I've got 10 as my fraction on the bottom. Now it's going to turn into that cross multiplication. All right, I get 10 times the quantity of x plus 6 equals 8 times the quantity of 2x plus 6. I can go through, I get 10x plus 60 equals 16x plus 48. All right, I can go through and I can start to simplify some things down. I'm going to minus the 10x to both sides, minus the 10x. So over here I get 6x. Okay, I'm going to minus the 48 at the same time. Again, I'm kind of combining some things here. I know you guys know what you're doing. This one gives me 12. My final answer, divide both sides by 6, x equals 2. Awesome. I know what x equals now. And now if I plug it back in to figure out that WR and that W or that RT. So again, if I plug in 2 into this problem, so this turns into 2 plus 6. So WR equals 8. This one, if I plug it in, would be 2 times 2 plus 6. 2 times 2 is 4. Plus 6 is going to be 10. So the length for RT is going to be 10. Again, we can solve for that variable, and then we can plug it back in. All right. On to the next example that we have. Okay, I'm going to zoom out just a smidge so you can work with it. Again, they wrote that stuff down. It does say that RS and UT are parallel. That's why they drew these triangles on the ends. RS, this length over here, is 4. Okay, and then the following one, RQ, that was going to be that x plus 3. QT on the opposite side is going to be the 2x plus 10. And then the UT is going to be 10. I'm going to go through and I'm going to kind of highlight the angles that'll match up with each other. Remember, we got vertical angles here. We do have a transversal. So using the opposite interior angles, these angles will match up. The other opposite interior, these angles will match up. So as I look at it, I can kind of piece together which ones I'm going to compare with. Okay. I'm going to say this will be my top number. This will be my bottom number, just so I can work with that. Okay. So in between my colors here, I've got the 10 on one side in between the purple and the green, and then I've got a 4 in between the purple and the green. So I know my first fraction is going to be 10 over 4 equals, and then I look at my other side in between the 1 arc and the green angle is going to be 2x plus 10. In between my green angle and my arc is going to be that x plus 3. Now I can go through, I can do cross multiplication. I get 10 times the quantity of x plus 3 equals 4 times the quantity of 2x plus 10. All right, I'm going to work through it. This gives me 10x plus 30 equals 8x plus 40. All right, I'm going to start working my way through. Minus 8x to both sides. That gives me 2x. So minus 30 to both sides. So that will give me equals 10. Divide both sides by 2. I'm left with x equaling 5. I am not done yet. Again, the x value equals 5. And what I'll do is I'm going to plug it back in. So I get 2 times 5 plus 10. So 2 times 5 is 10 plus 10. So the length of TQ, this length here, is going to equal 20. So I'll kind of put it underneath there. That's 20. Same thing. This x is going to turn into a 5. So I get 5 plus 3. 5 plus 3 is going to equal 8. So the total length of that one is going to be 8. All right, very last example for you. All right. Number 4, it says skyscrapers. He wants to have that height of the Sears Tower. Again, I've got those two triangles. I'm going to compare those two triangles. Okay, it's not drawn to scale. Just go with it. Realistically, I've got this triangle here, and this says it's 2 feet. This says it's 12 feet. I also have this triangle here that says this is 242 feet. This one is X feet. I can figure it out using those same proportions to figure out which ones are going to match up. Again, it's a right angle, so I know I got this angle. I know I got this angle. Using side angle, I can figure it out. I will do 2 over 242 equals 12 over X. I'm going to do my cross multiplication. So that gives me 2X over here. 12 times 242 is going to give me 2904. Divide both sides by 2. X is going to equal 1452. So the height of the Sears Tower is going to be 1,452 feet. Again, we're just finding those similar triangles, setting up those ratios and proportions, and you're able to find the height. Okay. Your homework for Thursday: 483, numbers 2 through 20 even. Thanks, guys.